Welcome back, everybody. In the last video, I said that before I start making games, I wanted to make a graphical user interface that we could reuse in all our games. Now, I did not want to reinvent the wheel, so I just picked any graphical user interface. I just happened to have a manual of a graphical interface called TurboVision, a very old interface. So I decided to go with that because I had the specifications for that. Now, again, we don't want to reinvent the wheels. I could go off this specification and build the code just on the description of the specification, but I know that in the internet, the source code of TurboVision is already available. So what I could do is I could find that source code that is operating system specific a little bit, but I could modify it to work for JavaScript to be a web browser graphical user interface. Now, I had a little problem last time at the end of the last video. When I tried to connect to the internet, I wasn't able to connect to the internet from Debian. So let's go to Firefox. And let's try to connect to a website, google.com. And when I try to connect, it gives me this error. It's not finding it. Now, the reason why it's doing this is because I did not set up any DNS servers in that Debian is pointing to. So it doesn't resolve the names with the IP address. So let's do that now. Okay, to set up DNS servers, we go here, wired connection, wired settings. Click here. And if I scroll down here, you see for DNS, the servers, I have nothing. I have nothing here. So I want to set that up. Now, since I'm actually running this on VirtualBox on the Windows, I could find out what my DNS, my DNS servers are supposed to be on the Windows. I could do this by clicking Start, typing command CMD, and when I get the Windows dialog box, I type ipconfig/all. This will actually give me the information about my DNS server. So if you see here, DNS servers, 209.18.47.61, 209.18.47.62. Those are my two DNS servers. So I'm going to set that up under Debian. I said it was 209.18.47.61. And the same address, but with 62 at the end. Okay, so let's apply. And we have to restart the server for the changes to take effect. And now we should be able to serve the internet. Let's just wait for it to restart. Okay, great. So now when I try to go to the internet, let's see what happens. So I'm gonna try to find something. The library is called TurboVision. So I'm gonna say TurboVision source code. That's what I want to find on the internet. And perfect. It's connecting to the internet now. So the first hit, TurboVision's port. I could pick any version. I could pick the Linux version or the Windows version. It doesn't really matter because we're not doing this for any specific operating system. We're doing this for the web, so we're gonna have to modify the code anyway. I'm gonna pick the one that is for Windows, but it really doesn't matter. You could pick any one. Okay, let's save it to a computer. And if it saved it, we should be able to go on the downloads and see it. There it is. So let's unzip it. And it should, all the source code should be here. So let's see. TurboVision, my classes. Let's see, window. And perfect. Here's all the source code to TurboVision. So I'm actually going to have to modify it a lot, but at least we don't have to reinvent the wheel. There's a lot of code that we could reuse. Some of the code we could reuse. Since we're going to do this, I know that one of the basic objects that I have to implement, since this is an operating system where we manage different windows and different dialog boxes, things of that nature, we're going to have two basic types that we're going to reuse a lot, which is the T-Rect, a rectangular type, which gives a description of a rectangular region on the screen, and more basic than that, team point, a point on the screen. So let's find those two objects, those two classes, T point. Here's T point. So right off the bat, we're going to start reusing some of the code. Okay, let's go back one. T point that we're actually going to call capital T P point PHP, and the other basic type that we use quite a bit is T-Rect. Now, if I look for T-Rect under the classes, I'm not going to find it. I'm going to PQRS. But I know it's under the include folder. So let's go under include. TurboVision Rect. Here it is. Here. Copy this. Okay, perfect. So let's rename this. One second. Okay, so if we see, here's the definition of T-Rect. You could declare it a few different ways. You could declare by specifying the 4 points, the X and Y of the top left corner and the X and Y of the bottom right corner. Or you could create it by specifying 2 points of point types, or you could create it by specifying no point at all. Now, doing this is actually something that I could do easily in JavaScript. But there's other things that this does, like operation overriding. Like here, checking if something is equal, if one record is equal to another record, things like that. There's actually no operation overloading in JavaScript. So we're gonna have to do the next best thing, which I'm gonna show you in a few seconds. So since T-Rect uses T-point, let's start with T-point. Here we go, the operation overriding the T-point does. So let's start by creating our T-point object. Let me erase this. Function. We specify the maximum number of parameters that it can pass, but then we write the code so it's flexible enough to handle all different types of parameters. So the most number of parameters that you could pass when you declare T-points are 2, the X and Y coordinates. So let's specify that. And then let's write the code for all types of parameters. Let's say you create a T-point and you don't pass any parameters, you don't pass any XY values, then it's going to have to go default to some value. So I'm going to default it to 0. So I'm going to say this X equals 0, this Y equals 0. Okay? Now let's say when you create a T-point, you pass it another T-point object. Instead of passing it the X and Y values, you pass it another T-point object. So it gets its coordinates from the other T-point object. So we have to write code for that. So we're going to check how many arguments are passed. If only one argument is passed, I'm going to assume this is of type T-point. It's another T-point object. If 2 arguments are passed, I'm going to assume they're actually the X and Y coordinates that were passed. So I could write code specific to that. So to make things flexible, I'm actually going to write a function called assign. Again, assign, you could pass it a maximum of 2 variables, the X and Y coordinates. But we're going to make this assign also flexible. We're going to say if the number of arguments you passed it is 1, we're going to assume it's of type T-point. If it's of type T-point, then it's the variable name is going to be X, because it's just the first variable gets assigned to the only value. if it's of type T point, then this dot x is going to be x, which is our T point object, and it has a field called x. And this dot y is going to be the x object, which is going to have a field called y. So if only one argument is passed, we're assuming it's of type T point, and we're going to reference its two x and y values, and we're going to assign it to this object. Otherwise, I'm not even going to check if it has two arguments. I'm going to assume it's of two arguments. So if it's of two arguments, then this x is going to get past the first value of x, and this y is going to get past the second value of y. So right now we have two ways of assigning it. We could assign it passing it a point object, or we could assign it passing it the xy object. If we do that, we execute the appropriate code. Now that we built this assign, we could go back to the creation when we create the object. If we create the object with no parameters, if you don't pass any x or y, it gets the default value of 0. If you only pass one parameter, which is x, then we're going to assume it's of T point, and we're going to call the assign function and pass it the T point, which is x. And if we pass both points, we're going to call the assign function, which shall also handle 2 points, and pass it the x, y values. Okay, perfect. So now we created a function. This is wrong, actually. It should say equals function. Now this is right. So T point prototype assign equals a function with a maximum of 2 points called x and y. If it has only one value pass, assume it's of type T point. If it has a 2 value pass, assume it's the x and y values. Perfect. Now for the operation override, there's actually no way to do operation override in JavaScript, but I'm going to do the next best thing, which is like creating a function which you could chain together. So I could say T point that add a point, and then right after the add, I could say that subtract another point, and we could just chain together the operations. The way we do this, I'm going to do it here, is by writing this function this way. Again, maximum of 2 variables. I'm going to rewrite the whole code. So it's going to look a little different. If the number of arguments passed equals 1, then I'm going to return. This is how we chain together. We not only assign we don't only do the subtracting that we want to do, but we assign it to a variable and return the variable. So by returning the variable, we could kind of chain them together. So I'm going to return a new T point, and this new T point I'm going to assign is this dot x minus x point x, since it's only one variable that we're passing. It's an object called x, and it has the subfield x and y's. this dot y minus x dot y. Okay. Otherwise this is assuming that it's using the 2 points. So we're going to return again. This is the trick of chaining together functions, is always return a variable in the function. So we could take the return value and kind of chain them together. We're going to create a new t point. And we're going to do this x minus x, comma this y minus y. Because in this in the second instance, we're passing both points, which is the x and y coordinate. Perfect. So right now, I'm going to show you how to chain together these operations. So this is how we subtract. We create a new point with the difference of the current point minus the arguments passed. So we're going to do the same thing for addition. The code is the same, except we're going to call this add. And instead of subtracting stuff, we're going to add stuff. So let's change the minus to plus. Okay. Two more operations that get override is the equal and not equal function. We really don't have to write a not equal function, so let's get rid of this, because if you write an equal, then you could call the equal function and just not it. So let's get rid of this. The equal function, I'm going to call it equal. Ooh. Function. And in this case, instead of doing the 2 points or the 1 point, I'm just going to pass it 1 point, okay? One second. I like to put brackets around it, because I think the way this JavaScript evaluates function is not exactly the same way the C does it. So what we do is we check if the value of this object, this x and this y, are equals to the value of the object that I passed it, the p object, px and py, and we return that value. So that's our equal function. Okay, so right now we have 4 functions. The assign function, where we assign it the value of the x and y coordinates or another point object, and the subtract, add, and equal function. Subtract subtracts a point from it, add adds a points to it, equal just check if the coordinates of this values is equal to the coordinates of a point called p. So let's save that. Okay. I'm not going to use it yet. I'm going to show you later on how to use both types. But let's move on to T-Rect. T-Rect, instead of being a point on the screen, is a rectangle on the screen. So it's a rectangle on the screen is pretty much made up of 3 points: the top left coordinates and the bottom right coordinates. And it has the ability to have different arguments. You could pass it the XY and the XY of the top right, and the XY of the of the top left and the XY of the bottom right, or you could pass it simply 2 points because the points have X and Y coordinates. Or again, if you don't pass it any points at all, it should default to 0. So what we're going to do is we're going to create a function. Let's get rid of this. First of all, before we create a function, this function is going to make use of the T-point object. So let's include the T-point object here. Okay, perfect. After we include that, let's create our function. Called T-Rect, which could have at most 4 variables. And I see that this is going to have some functions called move, grow, intersect, union, and it's going to do some operation override again, which is check if two values are equal, they're not equal, or if it's an empty box. We're going to get to that. And it has two variables, A and B, of type T-point. So we're going to modify the code. We're going to create the 2 T-points. Okay, great. So right off the bat, we've taken care of the fact when there's no values passed. When you create a T-Rect and no value passed. When you create a T-Rect and there's no value passed, it will create 2 points, point A and point B. And since we're creating the 2 points passing no values up here, it's going to default to 0. So it's going to have point A is going to have the X and Y 0, 0. Point B is going to have the X and Y 0, 0. So we've taken care of the fact that if you create this T-Rect without passing any arguments. Now let's see what are the other options. We have the options of when you just pass it one argument. If you pass it one argument, it's assuming that you're passing it another T-Rect object because the T-Rect has the 4 points that it needs. So let's say if it has one argument, it's going to assume it's of type T-Rect. We're going to write, this is going to also have a function called assign, which I haven't written, but I'm going to write it. And it's going to have the same thing. It's going to be able to have 1 argument, 2 argument, or 4 arguments. So I'm just going to be able to pass this the value. If it has 1 argument, I pass it the first variable, AX, which is actually the T-Rect. Else, if it has 2 arguments, it's going to assume that it's of both arguments are of type T-point. And again, I'm going to create this function, which I should be able just to call and just pass it the 2 T-points. Otherwise, if it has 4 arguments, it's gonna assume that you actually pass the x and y coordinates for both points. So you're gonna pass ax, ay, bx, and by. And again, I'm gonna call the assign argument, which I'm gonna create in a minute. And in the assign argument, I should be able to pass it all 4 points. Perfect. So passing the 4 arguments, we're going to take care of that. The passing the 2 points, we're going to take care of that. And the passing of no argument, we're going to take care of that. So how we're going to take care of that? We're going to write a function called called assign. Which is going to be a function that has at most 4 variables. And we're going to check all the different variations that we could have. So what we could have is 1 argument being passed. If 1 argument is being passed, we're going to assume that it is of type T-Rect. And type T-Rect has actually the 2 points. The type T-Rect has the 2 point A and B. So what we could do is say this, that A assign, remember the T point has also an assign function. And we pass it x a that A, and this that B that assign. Again, the rectangle is XA, which has a point B. So right now, if we're only passing 1 variable, which is going to be called XA because that's the first name on the list, it's going to be of type rect, and type rect has 2 points, point A and point B, and I'm just going to assign it to this 2 point, point A and point B of this current rectangle. And we're just going to keep on. Else if there's 2 arguments being passed, if there's 2 arguments being passed, I'm going to assume the 2 arguments of type T points. So it'll indicate the 2 points on the screen that we want to assign. So if we do this, the code is basically the same, except we're passing in the first 2 variable, which is AX and AY, which is actually 2 points, not actually what the description says. So we're going to say this A that assign XA, this B that assign YA. Those are the 2 point variables. The first 2 are actually of type 2 points, and since T point could handle the assignment of type T point, I just passed it the 2 points. And our final way is if we actually pass all 4 arguments. which I don't actually even have to check. I'm going to assume that otherwise it's 4 arguments. So I'm just going to say else. If I pass it the 4 arguments, then this dot a assign it the xa and the ya values, and this b assign it the xb and the yb variable. Okay, so now that I created a sign up here when I call it, if I pass it 1 value, it's going to assume it's of type T-Rect. If I pass it 2 values, it's going to assume it's each value is of type T-point. And if I pass it the 4 values, it's going to assume that each value is the x and y coordinates of each point. Perfect. Now I'm going to do one more thing. In the source code that I downloaded, there's no function called assign. I just created a function called assign. But in Pascal, which is where my manual that I have at home comes from, there's actually a function called copy that does the same thing as assign. So what I'm going to do, this should be a capital R. Is that I'm going to create a function called copy, and it's going to be the same as the function called assign. So right now, when I want to pass assign values to a record, I could either call assign or copy. They both do the same thing. Copy is because Pascal uses the word copy. Assign is because I decided to use assign when I rewrote the C code that I have. Okay, so what do we have next? We have these functions: move, grow, intersect, union, contains, and then these operations. We check if they're equal or if they're not equal. So let's start with move, with the function move. So we could say T-Rect tx prototype.move, and it has the 2 values, ax and ay, adx and ady. And I'm actually going to do the same thing for this. I'm going to assume that you could either pass both values, the x and y coordinates, or if you pass 1 value, it's going to be of type T points, which has the x and y coordinate. I'm going to make this function a little bit flexible also. So the way I'm going to do is I'm going to reuse this code down here. I'm just going to add a little bit of code on the top to add the flexibility of having 2 different types of arguments, either the x and y coordinates or another point. I'm going to do this by saying if arguments equals 1, if you pass it only 1 argument, assuming it's of type T point, is if of type T point, let's create a point called P, and assign it the point A dx. Otherwise, if you actually passed the 2 points, let's create a point called P, and assigning the A, the X, and A, the Y coordinates. So right now, this little code up here creates a variable P of type T point, and if I pass it a point, it just assigns it that point. If I pass it the two value, it assigns the two value. So now I created a point that works in either case. Now what I have to do now is I could use my add function that I created. So I could say this that A is equal to this dot A adding the point. This will take care of adding X. I'm calling the add function, which will add the X and Y coordinates of point P to point A. And then the results, I'm just storing it back in A. So I don't have to have AY. And I do the same thing for point B. Let's erase this. Okay, so let's look at this function again. What I did was I created a point, and the point has the either values of point ADX if this is a point, or the values of ADX and ADY if those are the two coordinates, and I just added it to A and B here, and then store the values back in A and B. So this actually does the moving of the function. I'm going to show you that later. So let's go to grow. Grow is very similar to move, except that instead of adding the point to A and adding the point to B, what I do is I subtract the point to A, so I'm growing out, and adding the point to B. So if I subtract the point to A, it grows in the left direction, and if I add the point to B, it grows in the right bottom direction. So what I'm going to do for grow is I'm actually going to just copy the same source code. Oh, one thing. Let me see. Hold on. Okay, I'm just going to do this just in case. I'm going to return this to when this function is called. So if I do this, I could actually chain the functions together, like in the add and subtract. I don't have to do this, but I'm going to do this just for that flexibility. So right now I'm going to take all this code. Actually, I'm going to copy the whole thing. I'm going to rewrite grow. This is grow. And again, I'm going to do the same thing. If one argument is passed, I'm going to create a point, a variable P, of point, or if the two values are passed, I'm going to create a point P with the two values. And what's going to change is here, instead of add, I'm going to have subtract. And in the bottom, I'm going to keep add. So that's the difference between grow and move. Move, I actually add the X and Y values to both coordinates. So essentially moving in whatever directions. Grow, I'm going to subtract from one end and add it to the other end. So I'm actually going to grow it out. Okay. Intersect is going to be pretty much identical to this. So what I'm going to do is I'm going to say intersect, I mean T-Rect. I'm not going to worry about being all flexible with this. I'm just going to assume that the variable being passed is of type T-Rect. So this, that AX is equal to the max of AX and RAX. Now in in JavaScript, the function called max is actually math.max. So what we have is this AX equals math.max, this AY comma RAXY. So we do this for this here. And this is how we reuse existing code. We just modify it to work under JavaScript. Again, it's math that min. We have to put the word this. Okay, so that's the algorithm for intersect. We already converted it to JavaScript. And intersect, the first two we run the function max, and the last two we run the function main. In union, looking at the code, it's the same exact code except you reverse it. On the top two you run min, and on the bottom two you run max. So I could copy the same function, override it, call this union because that was the name of the function, and just change min to max and max to min. Okay, so that's it. We already implemented this function. It's the same function except that we have a function called contains. We have a function called contains, which let's implement it right now. What does it return? We don't have to say that it's Boolean. We could just say, let's get rid of the Boolean. AX is this AX. Perfect. So we just modified the code to work in JavaScript. So that's how we're going to be reusing a lot of code. Okay. So this function checks if both points are equal. So we're going to rewrite this. We're going to pass it a rectangle, not a record, a rectangle. And we don't need to say Boolean. So let's get rid of this. Now we're going to have to expand on this a little bit. We can actually not, say A equals RA. These are two different points. Even if the points have the same values, if they're not pointing to the same exact point in memory, it's going to say it's not equal. And that's not what we want. So what we want to do is we want to specify each field. So we're going to say, first of all, it's this. We have to put full this A dot X equals R dot A dot X, and this we have to specify each field. And for B, okay, so for this we actually have to specify. We have to check every parameter. So now it's going to check if the two squares have the same values on all points, and if it does, it returns true. Otherwise, it returns false. Let me make sure that everything's fine. Seems fine. Okay. Not equals, we don't have to implement because we could just call equals and then not it. And is empty. Is empty. Let's implement it. This dot AX, this dot BX, or this dot AY, this dot BY. So if the A point is bigger than the B point, then it's an empty rectangle. B has to be the same or bigger than A. Streaming operations, we don't have to worry about that because we're not doing that in web-based application. So let me just save these two things. Okay, so I just created two functions, T-point and T-Rect, and I did it reusing the code that it was already existing. Now let me test it out. Okay. So we basically have to include the T-Rect object. And we're going to use T-point in T-Rect, but we don't have to specify T-point because T-Rect includes T-point already. Since T-Rect uses T-point, when I use T-Rect, T-point is going to be automatically available to me as well. I'm not going to be using any extend function, so let's get rid of this right now. Let's erase all this. So let me write two functions. Print point, where I pass it a point type, and I log to the console. Okay. So I'm gonna pass it. I'm gonna create a function called print point, which I pass it a point, and it just prints the x and y coordinates of that point to the console log. And I'm gonna write another function that does the same thing for the rectangle. Okay. Okay, so it's going to print out the coordinates of the rectangle to the console. So right now, let's create some points. Variable p1 equals new t point. Let's create a point passing in no parameters. Let's create another point passing in both parameters. And let's create another point passing it one parameter. Now, if you pass it one parameter, it has to be of type t point. So let's pass it 0.2 back to it. Now let's create also some variables where we mess around with the points. Let's create another point, 0.4. And 0.4 is going to be 0.2, but adding 0.3 to it. Remember the add function that we created? We could call it that add, and we could pass it either the x and y coordinates, or we could pass it another point. The same thing for subtract. Let's create another point. Instead of passing in another point, I'm actually going to pass it the coordinates. And finally, let's show how we could chain operations together. Let's create another point. And let's say we take 0.5. We add this point to it, this point. And then we subtract by chaining, and we just say point subtract. And we could subtract another point from it. So see here, we could do addition, subtraction in a long chain. We could take a point, we could add some coordinates to it, then we could subtract another coordinates to it just by doing a dot, add, dot, subtract, that move. We could just keep on adding that to the function without having to call it in separate lines. So now let's print all these things out to see what values we have. One second. Okay, so let's see what this value should be before we see the cancel lag. We create point P1. We didn't pass it any values, so P1 should be 0, 0. That's the default values. We create P2. We pass it 1 and 2, so P2, when we print it out, should be 1 and 2. We create P3. P3, we pass it P2. So P3 should be 1 and 2 also. P4 is actually P2 added to P3. So P2 added to P3 is 1, 2 plus 1, 2. This should be 2, 4. P5 is P4 minus 1, 1. So 2, 4 minus 1, 1 is 1, 3. This should be 1, 3. And then P6 is P5, which is 1, 3 added to 2. 1, 3 is 3, 5. And subtract P2, which is 1, 2, which whatever it is. We'll see what it is on the screen. So let's save this and let's see what it is on the screen. Okay. Okay, so we just created that. The values get stored in the console. And this is syntax error, unexpected token. Let's see where's the syntax error. I misspelled function in T point. So let's go back and fix that. Okay. Oh, we spelled that out here again. Okay, so let's see if that's fixed now. Let's rerun this. There's another syntax error. Let's see. Equals, I forgot to put the word function here in T-Rect. Let's save this. Let's go back. Let's run it. Perfect. So those are the values. First is for P1 is 0, 0 because we didn't specify any parameters and it defaults to 0, 0. Second one is 1, 2 because we specify the parameters 1, 2. The third one is 1, 2 again because we specify P2 as its parameters, as its value. So it copied this values down here, and so on and so forth. So this is fine. Let's try T-Rect now. 1 second. Okay, so right now we created these variables of type T-Rect. The first three variables we actually assign parameters. So A should be 0, 0, 100, 100. B should be the same. C should be 10, 10, 90, 90. We created a T-Rect of passing one parameter. When it's one parameter, it's assuming that it's of type T-Rect. So D is going to have the same value as C. E is a T-Rect made up of 2 points, P1 and P2. Now, if we go up here, P1 is 0, 0, P2 is 1, 2. So this T-Rect should be of 0, 0, 1, 2, of type 0, 0, 1, 2. And F is of rect not passing any parameters, so this should be 0, 0, 0, 0. Hold on, let's run this first. Okay, let's run this and let's see what we get. Okay, so the first three value was 0, 0, 100, 100, 0, 0, 100, 100, 10, 10, 90, 90. This is right so far. This was copying this one, so this is right. And this was copying this to 0.0012, so 0012. And this one didn't have any parameters passed, so 0000. So it's working fine. Let's just try a few more things. Okay, so now I modified D by moving it and growing it. In F, I said for it to copy C, which should be 10, 10, 90, 90. So let's see what we get now. Okay. So D, we did move and grow. So this is the new values. And for F, we copied this. So it's 10, 10, 90, 90. So it's working perfect. Okay. Now this, I haven't gotten to actually doing graphical stuff yet. By the next video, I'm going to get to doing it. But this video needed to show you how we're going to be reusing some code that is existing without having to reinvent the wheel. And these are the basic objects that are going to get reused a lot by the graphical elements of the JavaScript vision, which I'm renaming it, of the graphical user interface. So that's pretty much it. I'm going to leave it at that for now. And in the next video, hopefully we'll get to actually do some objects that manipulate things on the screen itself. Okay.